Hi, good morning, everyone. So, my name is Kuntal from American Bureau of Shipping. I'm part of the technology team and I'm based in Singapore. And I have been working on vessel electrification and modeling and simulation of complex systems such as green shipping corridors. And thank you for the opportunity to present my presentation over here. And we're very honored to share the stage with eminent experts in the industry. So, if I, from the previous presentation from our other speakers, I found a few keywords which are like it's a highly complex system. Paper is a highly complex system, and there is a indeed issue and uncertainties with infrastructure requirements, supply chain issues, high dependence on the fuel price, fuel availability, what kind of storages will be needed, and who pays for the fuel premium, and what is the impact of future regulations on the fuel on the operation of the shipping corridors. With that respect, we have kind of developed a simulation methodology which can be helped to answer a few questions. I will not say all of them, but it can be a starting point to answer a few questions on that. So I will present what are the foundational elements that has been considered in our modeling aspects, and what are the benefits, what is various roles, and provided on the time I will go into the modeling details as well. And also I will take an example of Singapore to Los Angeles Long Beach in shipping corridor, which we did the baselining study and present some of the results as well. So, introduction to green shipping corridor has been covered by our other eminent speakers, so I will not cover that. So I just want to highlight here is that we are considering the four basic foundational elements in the green shipping corridor. So which are the ship owners, ports and bunkering operators, and fuel suppliers, and also what are the specific corridor features, because all the corridors are different from one another. Some corridors are monofuel, some corridors are multiple fuel, some corridors have only container ships, bulk carriers, and so on. So every corridor will be different from one another. And also to enable the green shipping corridor, we need cross-value chain collaboration with considering the different fuel pathways, and also logistic and shipping impact cases, that means the market forces, and also what is the impact of different policies and regulation. So we have to consider all of them to understand, holistically understand what will be the outcome of the green shipping corridor in terms for all the stakeholders. So in terms of modeling, we have understood that it's a basic. If we go to the very basic, it's a supply-demand balance with some financial outputs. So supply means who are the fuel producers in the corridor, what is the cost of the fuel, availability of the fuel, and if the infrastructure is needed, is available in the ports and all. And demand is from the ship owners who will use the bunkering, will use the alternative fuels as bunkers. And also there may be some domestic demand as well, because ammonia is being and some other alternative fuels are being used by chemical and fertilizer industries. So those demand will also compete with the ship owners' shipping demand as well. Now we have divided the modeling into three aspects. So first one is the optimization. So in the optimization, we try to understand what is the long-term planning or long-term outcome or long-term forecast of the corridor. What is the potential fuel mix, how much storage is needed, how many vessels, new builds and retrofits are required, how much fuel should be procured from different sources, and so on. But this is a long-term overview. We need to also consider the short-term granular operations. For example, one of our speakers mentioned that there are complexities associated with bunkering operations. So 10 to 12 hours are required for the bunkering operations. So those aspects cannot be considered in the long-term planning, but it is more on the short-term operations. So what is that the long-term and the short-term, they work together to understand what is the impact of each of the operations on the shipping corridor initiatives and so on. And then we combine all of them and we calibrate all the model together to understand what is the impact of each of the factors on another, and so on. So we call it as a twin of green corridor. That means we try to represent how the corridor will look like in mathematical or science-based formulations. So here we have inputs and data pre-processing. That means we need to understand what kind of demand, what kind of future demand is expected, who are the possible suppliers of fuels, and what kind of policy and economy and industry trends are there which will impact the future shipping industry. Then, as discussed, the model comprises of resource planning and as well as the operational simulation model. They work coherently with each other, and the outputs is we try to amalgamate all of the results together in terms of data sets, and which can be used later on as well. And also we also understand what are the socio-economic assessments for each of the things. So we try to project it as a data set driven decision making. That means you can see that this is a potential dashboard in which you can select as your role, means you can be a ship owner, port operator, fuel supplier, and so on. You can select which kind of corridor you are interested in, and the planning dashboard will give you the what is the potential fuel mix, what is the potential TCO, and you can also simulate the details, the vessel operating details in calendar operations. So why we are going after this? So data set driven decision making is not a new concept. It has been used in the energy industry for a long time. For example, in India or in Korea, in all over the world, there is a huge push for decarbonizing the energy industry. So for any renewable company, if they want to invest in Korea or in India and so on, they have to develop a data set for the whole country before making informed financial decisions. So something very similar to that, if someone wants to enter in a green corridor consortium, so they also can leverage on this kind of analysis on data sets, existing data sets, and they can understand on current understanding of the market and potential scenarios, future scenarios, what kind of decisions they can make. So this data set is not a single time work, but it's a continuous upgrading of the data inputs, regulations, and so on. So it's a continuously developed model. So what are the benefits? So benefits, the key outcome is to create an integrated model for all the stakeholders in maritime ecosystem. For example, for the cargo and the ship owners, they can understand what kind of retrofit needs are required in future. What is the investment timeline and timeline of retirement and commissioning? And if you want to go into more details like what kind of energy saving devices are needed, if any voyage run optimization will help in savings of fuels or not, and forecasting the cost of ownership and the emission as well. For the fuel suppliers, because each of the ports will source the fuels from different countries or different local producers, they can also get an estimate like what kind of fuel demand will be there, what kind of production cost is there, how much shall I invest as a fuel supplier or a fuel producer, and what is the timeline for that investment as well, and who are my potential off-takers. So similar to this, ports and bunkering can also understand like what kind of infrastructure development is needed in future. And combining all of them, the corridor will give the aggregated overview like what is the future fuel mix in the corridor, what is the future fuel consumption, and is there any possibility of intermediary ports or bunkering, and also the emission forecast in the corridor. So in terms of our ABS roles, we help in facilitate the design and development. We do the corridor analysis, optimization of the whole system, and also provide advisory support and independent VNB of the whole value chain. So in these terms, we have many publications, but I want to highlight the three major publications. So first one was published, I think, 3 years back. It's mostly on the introduction, like how green shipping corridors are and what are the various terminologies, various stakeholders, and so on. And second is on the analysis methods, like how each of the green corridor can be analyzed. And the last one is on the case study on very specific Singapore to LLP corridor. So let me just discuss on the model description. So first one is the demand side analysis. So in the demand side analysis, the main objective is to understand what are the relevant voyages which should be considered in the corridor. We need to define the direct voyages or indirect voyages, and also define the voyage characteristics, and also need to estimate the energy demand for different vessel segments, and also estimate the baseline energy demand in the corridor. So what means is that, for example, if you see this figure, the top right figure, so this one we have considered the AIS data for all the vessels operating between 2021 and 2024. But when we want to analyze a particular corridor, for example, Singapore to LLP, we need to filter out all the other vessel segments because we want to be focused on the corridor segment. Otherwise, we will end up overestimating or underestimating the energy demand. So that's how. So that is the importance of traffic analysis. So we understand what kind of vessels are there, how much, how many how many port calls are they making, what kind of fuel sources, fuels they are consuming, and how much is the energy demand also by each of the vessels. So, so for some of the corridor insights, so this is taken from our publicly available report on Singapore to LLB corridor. So we can see that for this corridor, there are most of the voyages are 97.5%. They make one or more intermediary stops between Singapore to LLB, but only 2.5% is direct voyages. That is mostly done by the petroleum products because Singapore is one of the largest petroleum manufacturing state. And you can see that there are 606 voyages we have identified and made by 642 vessels. And container ship comprises of the most of the share, followed by petroleum products and ro-ro carriers and so on. So benefit of doing this analysis is to understand who might be the potential first movers, because we can identify who are the companies or operators who operate very frequently in the corridor, and we can approach to them in motivating them to join the green corridor and so on. So also in the corridor we have also identified the different intermediary port calls. For example, for the container vessels in China has a lot of intermediary port calls followed by Japan and Vietnam, and for the ro-ro vessels it's mostly in Japan and China as well. So the ro-ro, the intermediary port calls are also important to understand who might be the potential conquering locations in future, in addition to the start and end ports as well, and so that they can also understand and develop their own timelines in infrastructure development. So second one is the supply side analysis. So supply side analysis is mostly understanding what kind of fuels will be considered in the corridor. So in this corridor we have considered VLSFO LNG, where different variants of ammonia and methanol, and what are their prices and weight-to-weight emission factors and so on. And also fuel availability needs also to be considered, because we cannot assume that fuel will be available at all the ports at all the time, because that will not give a realistic results. So we need to consider also that. And the last one is the policy, economy, and industry trends. So first one is the emission targets. So we had considered two emission targets. One is for the IMO GMG strategy, and the second one is the Paris 1.5-degree scenario with various checkpoints. And then we also included some of the inputs and constraints, like what kind of vessels are there, what is the demand growth, order book status, and vessel costs associated. And also the constraints, like there will be different fuel blend ratio, fuel availability, minimum of take-out in fuels, and what are the vessel retirements and retrofitting strategies. So we included the very stringent constraints in that to make it a very, to not make it very academic exercise, but to make it fit to the real world. So we can see that the future order book status is mostly based on LNG followed by methanol, and some of the parts are for the biofuel and the ammonia as well. But still, the conventional fuel still has the largest share in the future order book, which is followed by the dual fuel engines as well. So the second one is from the modeling aspect. So we do the resource planning model. The main base is to minimize the total cost. The total cost is we have to invest in new capex or retrofitting, so that goes in the capital cost. And also you have the production cost, that means the offtake of fuel and basically the fuel cost. So you want to make a decision to understand perfect mix, basically how much mix should be there, adhering to my inputs and market demands and constraints and so that I get the net present value to be very minimal. So that's the main objective functions of the resource planning. So using the resource planning, we fit the results into the fleet and port operations. So fleet and port operations are, we can model very detailed operations from, like you can see from the left hand side, it shows the vessel operations, whereas on the right hand side it shows the berthing and the port operations, where you can see the vessels going out, vessels coming in, and also some of the bunkering operations also happening. So those kind of more intricate details also you can include in the model. So after this, we are aiming to do scenario-based analysis based on the data set. That means we have the corridor, we have various inputs and constraints and so on. We want to understand for a particular scenario, for a particular stakeholder, what is the output. So that's the role of the data set. So you can see for the fuel mix, for the IMO and fuel mix for the Paris 1.5 degree scenarios will be different because the stringent level or the emission requirements are different, are significantly different from each other. And also we can also see what is the base case, that means all the fuels are available, and also what if there is no biomass available for the operations, or there are no ammonia and so on, then what is the impact of the fuel mix in the whole world. So that's also we can use the model to assess. And the last one is on the socio-economic aspect, because at the end, the whole corridor, the whole exercise is to make the world a better place, to reduce the emissions, and also to understand what is the impact of the socio-economic cost. And so we can use the analysis to understand the future opportunities, like what is the land use planning, urban sustainability, what is the climate transition risk, and what is the impact on the infrastructure development. And also we can understand like what is the community level opportunities, like green employment, what is the improvement of air quality, and so also food level opportunities as well, like congestion improvement, environment sustainability, food management, and what kind of reskilling and upskilling of the manpower is needed to make this happen. And also, this is the national level opportunity. It can be merged with the national level decarbonization strategy. It can be seen like how the shipping can really impact the national planning, and also what is the impact of cross-border R&D ecosystems and national and sectoral decarbonization plans. So that's all from my